So let's introduce the first speaker, which is Samuele Lilli. Hello, Samuel.
Hi, Scoop. How are you?
I'm good. How are you?
I'm good, thank you.
Are you excited for today?
Yeah, of course.
So I saw in the information about you that you've been working for 10 years already at your current job.
No, 10 years in PHP, but
PHP.
5 years. Yeah, 5 years at Microsoft, and we are also sponsoring this event.
Yeah, exactly. A lot of developers don't stay for 5 years at a company. Why is it so interesting to be in the same company for 5 years?
Well, because to me it starts with a large monolith that had to be modified in the time. So I've seen the project from the start, because when I joined Microsoft, there were only one developer. Now we are, I suppose, 8 at backend, 2 for frontend, and 2 for DevOps, if I'm not mistaken.
Right.
And yeah, so to me, Nuvola, our project is named Nuvola. And is a software as a service, for schools. And to me, is like my baby, if I so to speak. So yeah, I stayed there because I've seen the project from the start to till now. So yeah.
So what's your biggest challenge at this point?
Nice question. I think to improve myself with and to let my colleague improve with me in this in this journey. Yeah, that's the most important thing to me, because we don't just write code. We think about code. Because to me, being a software developer is to tackle problems. It's not really about the syntax or the language or to write code, if you know what I mean. The typing on the keyboard is just an action.
Yeah.
And our domain and business is quite challenging. So yeah, every few months we have such a difficult task to think, to tackle, to analyze, and to design, and then to put in production and roll out in production. So yeah, that's the biggest challenge.
Okay, let's go to your talk. You're going to be talking about mocking. Why?
Yeah. Yeah, because I've seen in open source world, talking about open source world, that everyone seems to be obsessed about mocks, and they are abused everywhere, literally everywhere. But sometimes it's not the right choice, and you will see why, or at least I try to explain why. And well, one thing that because my talk was recorded beforehand, but one thing that I didn't claim in the talk is that when you do the red-green refactor cycle of TDD, you can see it pretty much like doing a Rubik cube. You know, the Rubik cube. Yeah. So maybe you have a surface with all the colors setted, but you have the corner that are not good. So mocks are very useful for this kind of situation when you design a class and you have let's say 2 collaborators, okay, and you don't have yet the implementation of them. And in this case, you can use mocks because you are designing the main class and not the collaborators. When you have finished to design the main class, you switch to one of the mocks, you implement it, and then as in a Rubik cube, you come back and substitute, if you can, the real implementation. It's and you will see in the talk, it's not valid for for every collaborator, sorry, but most of the time you can think and rethink about what you're doing in TDD. So that's the goal, the ultimate goal of the talk, to put to let you grasp something that maybe you didn't think before.
Okay, well, that sounds great. One practical thing for the people that have questions, please ask them in the stage chat so I can see them. And after the talk, I will be able to ask you the questions, Samuel. So thank you very much. And we're going to watch your talk now.
Yep. See you later.
Hello everybody, and welcome to this presentation where I'm gonna talk about TDD and why you should stop using mocks blindlessly in your test code. In this talk I won't use slides, just code examples, and this talk is a mid-level one, so I'm not gonna focus on unit testing basics, but I will occasionally stop to explain something more in detail. Moreover, I have chosen to use two different testing tools, which are PHP Spec and PHPUnit, to point out that issues that may arise with mocks and stubs and test doubles in general are not due to the test library you may choose, but rather than to the methodology. And for time reason, I won't be able to show you at each step test written with both tools. And for this session, I have chosen to use PHP Spec. But if you're interested in PHPUnit code also, I'm going to share it in my GitHub account shortly after the presentation. Okay, so let's go straight to the code. We start from an invoice class, which is a trivia class that represents an invoice and can have three different status: new, paid, and partially paid. And when you create an invoice, you have to provide an amount of money, which is represented here by the money library, and a due date, which is a datetime interface. When you create a new invoice, its status will be new. And then we have a bunch of methods to check the status. So if it's new, if it's paid, if it's partially paid, and so on. And also we have a method to check if invoice is overdue at a certain date, a method to retrieve the due date, and to check if interest can be applied, and to pay an amount of money for this invoice. For the first example, let's pretend that someone from the business department comes and asks for a functionality to know that will be used to know the amount of money of overdue invoices at a certain date. Okay, so okay, we start from the test, the PHP Spec Test. So I have written a class which name is overdue invoices calculator, and that is used to fulfill the requirements from business department. And in PHP Spec, it's worth to notice that let function is the same as setup function for PHPUnit. And when you type in an argument, PHP Spec itself will create the test double for you. In this case, a stub of invoice repo. And the second thing that is worth to notice is that when you write a test in PHP Spec that is called example, when you type in the same argument of let function, so same type and same name of the argument, PHP Spec itself will inject the same mock that it's used in this case to create the overdue invoices calculator. Sorry. And so we have 4 stubs, one for the invoice repo and the other 3 for invoices. The invoice repo is there because we want to split the responsibility of retrieving the invoices from the responsibility of them, the overdue, of course. And we have 3 different invoices because we want to be sure that not overdue invoice like invoice 2 won't be taken into account in the summary, in the sum, sorry. And whereas the other two's, invoice 1 and invoice 3, are, and we have 2 different invoices, overdue invoices, because we want to check that get amount due at a certain date is the sum of to pay amount of first invoice plus to pay amount of the third invoice. And as you can see, this is overdue, this is overdue, whereas that's not. This approach use all stubs. If we run tests, both PHPUnit and PHPSpec are green. So let's check what changes when we use real implementation. Oh, sorry, I didn't show you the code, of course. So we have the invoice in memory repo passed as a dependency of overdue invoices calculator, and we don't have any implementation for this, so we are stubbing it in test code. And through invoice repo we find all the invoices, then we filter out all the not overdue invoices, and with the array das we add starting from 0 all the amount to pay of overdue invoices, so nothing fancy. Okay, so let's go straight to the test code with the real implementation. So we have basically the same example as before, and we the only difference is that in this case we are creating real invoices, so real implementation is used, and to let invoice 1 and invoice 3 to be overdue, we modify the request date to a date before of the original request date, and we expect the same amount at a certain date of overdue invoices. And yeah, okay, cool, everything is green. But let's pretend for a moment that from business department a new request kicks in and says, okay, we don't only want to have the sum of overdue invoices, but we also want to apply some interest if invoices are overdue by more than, let's say, 7 days. Okay, so what I have done. Okay. Basically, I written a new example. It applies 10% interest if invoice overdue by more than 7 days. I still use all mocks, and I have only one invoice which is overdue, and which due date is 8 days before, so is more than 7 days, and the amount to pay is 100 euros, and so I expect the 10%, which is 10 in this case, of interest to be applied. One thing that is worth to notice in this case is that I have defined in this example a new interaction with invoice, which is getDueDate method. As you can see in the first example, I didn't change anything, and this method invocation is simply not there. And that's basically fine from my standpoint, because the focus of the first example is to sum all overdue invoices, and so it should not take care of due date, which has no meaning, basically no meaning in this scenario, whereas in this has. But as I'm using all stubs, as we will see shortly, this will cause the first test to fail, and we will see shortly. Okay, so how the test code, the system under test code changes? Well, basically nothing fancy. So we have a new method, have to apply interest, and if the due date diff with the request date is more than this constant, which is 7, then we have to apply interest percentage, which is 10. In the other case, the calculator behaved as the same as before. So going back to our test, if we run PHP Spec or PHPUnit, it won't make difference. Sorry, but we don't have green test, and that's because if you look carefully, the test that is failing, as I anticipated before, is the first test, not the second one. And the reasons why this is failing is because get due date must return the time interface, and we can check here. Okay. So basically, as we didn't explicitly declare in first test what get due date will return when it's called, PHP Spec, but also PHPUnit tries to return a null value, but this breaks PHP language rules, because you cannot return null, as we expect. We declare to return at the time interface in this context. And I have to fix this example, but from my standpoint, this has no sense, because, well, whatever I do in this scenario, in this first scenario with due date, it's something that doesn't change the behavior of first test at all. So yeah, from my standpoint, this is a logical coupling between system under test and test code, because to fix it, as you will see, I needed to add all the interactions with get due date on all the invoices. This brings also cognitive load, because who reads this test should take into account an additional information which is not required in this context, and moreover we are forced to provide a value for this method which won't break the test. So I need to think carefully about this value in order to don't break the test. Sorry, and that's bad, because I have changed something that is not strictly related to the first test, and I was forced to change it. Let's check what happens in the scenario where I use real implementations. With no surprise, first test is untouched, and the second test that is the same test as before, but with the real implementations. So as you can see, I create a new invoice and I modify the request date by 8 days before request date, and then I expect the interest to be applied, and nothing more, nothing less. If I run tests, they pass. Oh, I forgotten to show you that after the fix I shown before, the tests were green, but trust me, they were, because I added. Okay, but if you don't trust me, I switch back to previous example and show you that they are green. Okay, cool. Okay, so you maybe think that this is the only issue with test doubles, and the only issue is related to PHP language itself and to its typing system. But yeah, let's just pretend that from the business department someone come and say, okay, we want a slight modification to the previous functionality, and we want to prevent interest to be applied if invoice has this attribute set it to true. So if interest can't be applied, basically. I want to focus on the return value of this method, because it may return null or bool. And so the client which calls this method is free to decide if null is returned to act as if it was true or false. So if you didn't understand it, I have made this example just to show you that the nullable value compared to the example before, where I have no null, where I have had not nullable return value. In this case I have, and this won't prevent me to get in trouble again, because sorry, I have to also show you the new test code and new behavior of calculator. Okay, so test code is changed only with an addition of a new example. It does not apply 10% interest if invoice overdue by more than 7 days, but invoice with not interest. So I've added a new interaction with invoice, and interest in this case, in this scenario, can't be applied. Okay, and the calculator is changed. Don't pay attention to this. It was an old error that should have been in the previous commit. But basically, if overdue by more than 7 days, let's check for interest to be applied, and if null, yeah, just apply interest. Otherwise, if true, apply interest. If false, don't apply them. Okay, so as I shown before, the PHP spec code wasn't changed, just an addition. Well, when I run test either in PHP Spec and PHPUnit, I have not passing test. In PHP Spec, because Prophecy, which is the mocking library of PHP Spec, forces you somehow to declare explicitly all the interactions, even if they can return null, all the interaction with your test doubles. So basically he said, okay, this is not a failing test, but semantically it's basically the same, because he said, okay, I expect you to invoke isOverdue, getDueDate, and getAmountToPay methods with these arguments. But now I have registered that you had called can interest be applied, and I was not expecting this to happen. So you have to fix your test, and the same goes with PHP Spec, PHPUnit. Sorry, when you use Prophecy as mocking library. I didn't show you before, but I have written test with PHPUnit relying on Prophecy for mocks and another PHPUnit file relying on PHPUnit built-in library itself for mocking. And what is broken here is only the one with Prophecy, but this is only a chance, because we are treating null value here as true, so interest can be applied, and so the last test, which will return null and where I have to apply interest, is still passing. But if I switch this and run again only PHPUnit, yeah, before there were one error and now there are two failures. So it's only by chance that previous test was passing. So how can I fix this with no surprise again? I had to add the interaction with can interest be applied here, and even if I were not forced, also with in the first example, I was not forced because first example execution path won't reach this call, and so the test is not broken, and it won't be. But to be sure that PHP Spec won't execute in a broken, so the purple status you have seen before, to be sure that it won't be broken in future if, let's pretend that the implementation changes, and I don't want it to be broken, I want it to be failing. As I said before, it's pretty much the same, but it has some differences from my standpoint. And so again, I was forced somehow to modify again the first example, which behavior isn't changed. The second one, yeah, it's kind of legit to have it to have to modify it, but again, yeah, these show a one-to-one relationship with between your code, test code, and system under test code. So again, if system under test code changes, I was forced to change the test code as well. Okay, so yeah, now tests are green and the implementation. I have shown you the implementation before and nothing changed. Let's check out to the example with real implementation. Don't pay attention to this. We will return to this line soon and focus on the new example. So in the new example, we have created an invoice and we state that interest can't be applied, and yeah, basically it's the same example as before with mocks. And okay, in the diff there is this that I will comment out just for a moment. And well, as you can see, tests are passing. Why did I add this line of code even if I wasn't forced to do so? Well, just because I want to have a coherent status for my test. So as in this case interest have to be applied, I prefer to be explicit about it. And yeah, that's because if I change this to false, I am safe. But as I shown you before, yeah, only PHP Spec code was failing because I comment out this line only on PHP Spec, but it goes the same for PHPUnit. So as you can see, with real implementation, there's no logical coupling between test code and system under test code. So my job was easier and I prevent myself to have headaches. And yeah, so we have seen the return type not nullable, and that I had to fix the test. We have seen a new interaction and I had to fix the test. And now let's say that the request for changes in the system under test code now don't come from business department, but from technical one. And let's say that why we want to retrieve all the invoices, which can be a large number, and why don't we retrieve only the already overdue invoices for a certain at a certain date? So to do this, to do this I have modified, well, I had written the real implementation for invoice in memory repo, and then I have added a new method, which is find all with due date before, which directly from repo will return only overdue invoices. And as you can see here, the calculator changed it this way. Why only new method invocation, and why didn't I get rid of this? I mean, I retrieve all overdue invoices at a certain date. Why have I to left here this code? And the answer is just for this example, because from the standpoint, from the point of view of overdue invoices calculator, the behavior isn't changed at all. And if you think about this carefully, this is true, because yeah, we are retrieving not all the invoices but only the overdue ones. But all in all, we are just retrieving invoices from repo, full stop. So the behavior again of my overdue invoices calculator isn't changed, even if it can be, even if I can get rid of this, for the moment it isn't changed. But if you, and of course I didn't written a new test for this, yeah, because basically this was the previous diff, and I hopefully don't have to adapt test code again. But if we run PHPUnit and PHPSpec, yeah, we get in trouble again, because PHP Spec and PHPUnit with Prophecy runs again in the same error as before. So from their standpoint, there is a new interaction, and also there is the type hinting type system, sorry, broken. And for PHP unit without Prophecy, well, as I changed the interaction, it just returned null, or an empty array, and so the amount won't be the same as I expect. But that's kind of crazy, because I mean, the behavior, let's focus for a moment on the behavior. The behavior of the calculator isn't changed. I just changed the way I retrieve the invoices. Why have I to be forced to adapt the test code? It's kind of crazy, and it's a terrible waste of time. And to fix this, I had, with no surprise, to change in all examples the method invocation. Again, because we are in the scenario where we're using all stubs. And what changed in this scenario with real implementations? Well, okay, I have two commits in one, so forgive me, but I get rid of invoice in memory repo, and I use the real implementation, and then I changed the method. But basically, maybe it's not clear from there, but basically I didn't have to adapt my test code, and I will show you that I'm not a liar by it's just this, because as you can see, I have I still have in this scenario the find all, so cool. This is the proof that I didn't have to adapt my test. I just got rid of the unique, the last and unique stub, and test code isn't changed, or it has a change just because I wanted to use the re-implementation, but it wasn't changed. And if I take advantage of the new method, you will see that oh, how beautiful it is. Sorry, it's, to me, it's very, it's a pleasure to code and to have this kind of feedback as quick as possible. And if I don't use mocks and test double, I don't have to adapt my test code, and this is incredibly satisfying. So we have seen that troubles with mocks and stubs are there when I break the PHP type system, when I add a new interaction, when I change a method but I don't change the the behavior, and so on and so on and so on. So a lot of logical coupling and a lot of possible troubles. Okay, and now let's say that we won't provide an abstraction for invoice in memory repo. So let's say that we want to create an interface. I will show you only the case, the scenario, sorry, with real implementations. So I have created the interface, and now as I'm in the scenario of real implementation, how can I create a new object from an interface? That's of course not possible. So if I have interface, how can I behave? What have I to do to have a real implementation? Yeah, basically I can use an anonymous class, for example, which is not my case here, and I just created an external file which name is invoice repository dummy interface, and implements the invoice repository interface and provide all the return types and methods and so on that I expect and that I use in my test. So as you can see, I don't use anymore the invoice in memory repository, and I use the invoice repository dummy interface. No one prevent me to use the real implementation invoice in memory repo, which implements that interface, but but actually, as I'm providing an abstraction with interface, I want to stay far away from real objects and real classes of my system under test class. In this case, because I just want to instruct my objects to return something which won't break my test, and this will be clearer in the next step when I will show you the only possible issue with the real implementation. And I'm gonna do it shortly. Yeah. So let's say that, as you can see from git commit message, that we have introduced a bug on invoice, and the bug is in this one. Yeah, so I have checked out to the right. Yeah. Oh, sorry. Okay, so before I was checking for greater than equal, and then I'm checking, oh sorry, before I was checking for greater for the due date, and now I check for greater or equal, and that's clearly a bug. In the scenario with all mocks, which I won't show you for time reason, this bug won't eat your test code, because you never run the real implementation, as mock will return the value that you claim that it need to return. But in this case, where I use real implementations, if I run tests, yeah, they fails. they fails because of this bug. And yeah, I hear you, and you said, well, but unit tests should be isolated, and yeah, they should not fail. The overdue invoices calculator should not fail if invoice have a bug. But that's not true. That's really not true. The isolation meaning here is that you don't have to rely on the execution order of your test, and that you and that the test running should be idempotent. So if I run it one time or couple or dozen of times, it should give me the same result every time. And moreover, if you follow the red-green refactor methodology of TDD, it's pretty straightforward to isolate the buggy code and to fix it. Yeah, so as you can see, I have changed only one line of code. I run again my unit tests, which are very fast. And yeah, I don't have only overdue invoices calculator failing test, but also invoices calculator test failing. I didn't show you before because they are not interesting, but yeah, I have also them. And if I make a git diff, which I can't at the moment because I use tags and it could be cumbersome to do so, but if you git diff this, you clearly understand where the bug and the buggy code is. So from my point of view, this is really not a problem. And at the end of the presentation and in the repo, I will share an article written by Martin Fowler, where he explained better than me what what is the meaning of unit word in unit test. For Martin Fowler, a unit is not a class or not a method or not just a portion of your code, an isolated portion of your code. For Martin Fowler, a unit is just a portion of your program that you choose to test, full stop, in isolation, so without database, without file system and network and so on. So a unit can be 2 classes, 3 classes, just one method, just one class, and so on. And so yeah, I'm not breaking the TDD golden rules, let's in quotation. Okay, so that was the last example, and to summary and to conclude this, if you have followed me, maybe you have understood why you should stop use mocks as more as possible. But the next question is, so are the mocks and stubs and test doubles in general totally useless? The answer is of course not, because you can use test doubles when you, let's say, reach the integration level or end-to-end level, or no, integration level, yeah, not end-to-end, sorry. So when you're interacting with something different than your controlled system, that can cause failures to your test. So I'm talking about file system that can change the status from write and read to read only, let's say, or when you run out of space disk and so on. Also databases, because there can be problem of speed of unique indexes. You have to create fixtures, and yeah, TDD forces you somehow to have a fast cycle. So yeah, it's you cannot use that database for TDD test. Also network, because you should be allowed to run tests when you're offline, and your test should not be affected on third-party service responses, let's say, yeah, and so on and so on and so on. So in all of these cases, of these scenarios, you are allowed to use test doubles. And to conclude, another scenario, maybe the interesting one is when you test legacy code where it is cumbersome to follow every execution path and to create something usable. So in those cases, before refactoring, is perfectly fine to use mocks. And another scenario that I imagined right now is when object creation is cumbersome, because as you've seen, creating an invoice in my example was really straightforward. But let's think about nested object and nested dependency. So when you have a dependency which relies on another dependency, and so on and so on. Even in this case, sometimes is fine to use mocks and stubs. So that's it. Thanks again for having me this year. Remember that we are hiring, and to leave a feedback on joined-in for this talk. And hopefully now you understand why using mocks blindlessly is not the right choice. Thank you again. Bye.
Well, there we are again. Hi, Samuel.
Hi.
Thank you for the interesting talk. That was already amazing. If anyone has any questions, please ask them in the stage chat. I will be keeping an eye on the stage chat to see if there are any questions. So far, at least, people are giving you applause, so that's good.
Yep.
Let me start with a question for myself. How do you come up with a talk like this? Why? What is it that you think? Okay, I need people to know about this.
Yeah, basically, as I said before, because I see that especially in the open source world, there are an abuse of test doubles, and moreover, there's a lot of confusion about what a mock is or what a stub is. You know what I mean? Something you can see in open source code, that there are expectations that also returns a value. So these should be called and will return. And we all go, and either I have done in past. So we go blindlessly to this kind of syntax without asking ourselves, is this the right way? And when I write tests for our software, which has a lot of legacy classes, I run every time in this trouble, and I started to think, oh, that's not the way we should do. Because yeah, is it true that at the end of the day the test should prevent you to introduce regressions, but also should be flexible and easy to modify them. Otherwise, if you have one feature that takes you, let's say, 5 minutes, and then you have to fix the test and say, and it takes, let's say, another 5 minutes, you're basically doubling the time and test up. Yeah, they should not. They should point out that a regression is introduced, but also that they should not be they should not be a problem for you, if you know what I mean.
Yeah, I understand. So now the next question is, if I inherit an old code base that is full of mocks, what is the easiest way to start to refactor it to use less mocks?
Oh, cool. Well, that's not a silver bullet for this. I think that the right choice is to write a wider range test, let's say an end-to-end test or a functional test, to test all the execution path that normally you won't do, because you know the test pyramid, no? So you have a lot of permutation of a unit, and also only the tests that give you certain business value on the layer on the upper layer. Yeah. So the first thing is to write to somehow switch the view on the unit the unit testing pyramid, and to write a lot of permutation tests for end-to-end or functional tests. Then start to if possible, of course, start to refactor your code. This way you have a security guard for let's say a watchdog for the old functionality, and so you're free to refactor it. And when you have it simplified, and you have all classes that does only one thing, this is the point where you can switch from mocks and test doubles to real implementation. But of course, as I said before, if your classes has a lot of dependency or as a lot of complexity when you create them, yeah, basically there's no silver bullet. It's not, there's not a solution, a universal solution for this.
Okay, so first refactor the code base itself, and then finally we can remove the mocks.
Yeah, remember the Rubik cube analogy that I said before? Yeah, so you are in a stable status, you have tests that are passing, but you should invert the corners in order to do the next steps in the Rubik cube. Yeah.
Okay. I don't see any more questions. I would like to mention that you are sharing the code on GitHub, I think.
Yeah, I already shared the link in the chat, on the stage chat. Yeah, so I share it again just to be sure that no one. Okay.
Okay. Well, thank you very much for being here. Everyone, please rate the talk on Joined In so that Samuel gets some feedback and the organizers get some feedback about this talk. Yeah. Thank you very much for being here, Samuel.
Thanks for having me, and hopefully it was an interesting talk.
For sure.
Okay, thank you.